Hello, everyone. This section is about the fundamental theorem of calculus, and this is a very important theorem. It tells us how to evaluate definite integrals. Okay. One of the things we can do is we can use the fundamental theorem of calculus to evaluate definite integrals. So let me just walk through the first example in this section here. And the problem is use the fundamental theorem of calculus to find the area of the region under the graph of f(x) equal to x squared on the interval from 0 to 1. Okay, so we need to find the area of the region under the curve. And we don't have to draw the graph. We know this is a parabola. Okay, so from 0 to 1. Okay. So we want to find the area under the curve. Okay. And above the x-axis. All right. So as we already learned in the previous section, the area of the region under the graph of f, okay, the function is a definite integral of f. Okay. So the area of the region on the graph f on the interval from 0 to 1 is the definite integral of f over the integral from 0 to 1. So this is the one thing we have to know first. Okay. The definite integral is defined as the curve, as the area of the region under the curve. That's the definition. Okay. So then what it means is that just need to evaluate the integral of what? Okay. F of x from 0 to 1. So that's the in the first step, we have to figure out what we want to do, what we need to do. Okay. So then we just use the rules for integration to evaluate this integral. Okay. So now f(x) is just x squared, so we can replace f(x) by x squared. We call it the integrand. So let me just copy this one here. Okay, so how do we evaluate this definite integral? The fundamental theorem of calculus tells us that in order to evaluate a definite integral, you need to find the a antiderivative of the integrand x squared, and then just evaluate the antiderivative. You find the two limits of integration and subtract 0 and 1. These are the endpoints of the interval, but they are also called in here lower and upper limits of integration. Okay, so according to the fundamental theorem of calculus, we need to find the antiderivative of x squared, and we know how to do that. if you still remember the power rule for integration, it says when you try to integrate a power function, you just add 1 to the exponent and then divide the exponent plus 1. Okay, so that's one antiderivative we found. And then we need to evaluate the antiderivative we found at the two endpoints, or the two lower and uppers of integration. Okay, so and then subtract. So let me just put the notation here. Okay, so we need to evaluate the antiderivative. We found that 1 is 0 and subtract. So this is the notation. So this means we need to evaluate this function at 1, 0 for x and subtract. So you know, 2 plus 1 is just 3. So the antiderivative we found is just x cubed over 3. Oh, wait. Come on. And then we just evaluate that function at 1, 0, and subtract. So you just plug in 1 for x, evaluate this function, and plug in 0 for x in this function, and then subtract them. So we got 1 cube over 3. If you plug in 1 for x, 1 cube over 3, and then if we plug in 0 for x for this function, you get 0 cube over 3. And remember, you always subtract the lower part from the upper part. Okay. So 1 cube is 1, so we got 1 over 3. Okay, in the first term, and 0 cube is 0, and 0 over 3 is of course 0. So at the end, the final answer is 1/3. Okay, so that's the answer. The area of the region on the graph of x squared y equal to x squared, the parabola from 0 to 1 is 1/3. Okay.